Hello, everybody. I hope you all can hear me. So as I said, today we're going to talk about DDD on the front end, theory and practice. I want to make a quick introduction. So my name is Talysson Oliveira. I'm a software architect and technical development manager at CodeMiner42. My username in most of the internet is TalysonLC, if you want to look for me. For you that don't know us, CodeMiner42 is a software boutique in Brazil, mostly specialized in Ruby and JavaScript. Okay, so without further ado, I want to start with an example of a project management tool. So I'm going to list some of the business rules of this project management tool. You don't need to focus on all of them. It's just to set a scenario that we're going to use throughout the whole talk. So this project management tool is an app that supports multiple teams. A team is a group of people that work together toward a common goal. Each team can have multiple projects. A project is a continuous or finite plan to achieve a goal. A user of the app can be a member of multiple teams. And inside the team, a member can be a participant of multiple projects. A project contains multiple tasks that can either be a feature, a chore, or a bug fix. And each task can be in the status of unplanned, unstarted, started, finished, accepted. And again, I know it's a lot of business rules. You don't need to focus on all of them. And of course, our actual project would have way more than that, but we can just focus on that for now. So after some conversation with the people on the team and the UX team and the product people, they got to elaborate this context map for the project, where you have the task-bounded context, the teams and project-bounded context, and then the identity and access-bounded context and their relation. But you can see that we don't have the front end there. Like, it seems like we shouldn't think about it, but if you think about it, we don't see where the front end would fit in this case. So how do we discover the front end domain model? Of course, as front end developers, the first thing we're going to do before implementing anything, we just check the mockups, right? So we go back to the mockups that the design team provided us, and we begin to browsing around and checking and looking if there's something that is familiar there. And then after some minutes, trying to find if there's something different from what you saw from the context map before and the conversation with the backend people, there's just something that is undeniable that you can see there. Okay, so the one thing that you can't deny that you see in this is that the design team loves Lord of the Rings a lot. And this is the most important thing that you can see there. But besides that, there's nothing else important or very different from what you saw in the previous conversation. There's nothing specific to the domain model of the front end. So we, as DDD practitioners, we go and talk to the domain experts to see what can be said about the domain model of the front end. And also the UX team. They're mostly in sync with the product team and the domain experts, and they already know what are the names that the domain expert use for stuff. So when you talk to them, they're going to ask you, okay, did you check the mockups? And you say, okay, I did check, but I didn't understand a lot of stuff. Like, there's just a bunch of elements and buttons and stuff like that. I'm going to need some explanation. So they go back to the mockups with you, but now they start pointing and naming things for you. So they say, okay, so this is the board. And the board is divided into 3 columns. And each column is, the content of each column is based on the status of the tasks that are inside these columns. And the backlog and the accepted columns, they're divided into sprints. And each sprint is divided based on the estimate of a task and also in the project velocity, which is something that we get from the backend somehow, but we can also simulate a different velocity only on the front end. If a task does not have an estimate, the user is going to see a selector to check one of the estimates to set it to the task. And you can also change the order of the tasks to make the priority different, but only between tasks that are in the same state. You can change it if they're in different states. So if the user clicks the plus task button there on the top right, they're going to see a form that is a draft for a new task, where they're going to fill the data for the new task and try to save. And then once one of the tasks are already accepted, nothing can be changing on that task. And again, they talk a lot more about the stuff, but at this point, there's just so much information that you can't observe anymore. But what you have right now is a cloud of new terms that you didn't hear before from the conversation with the backend people and the product people regarding the context map that you saw before. And it's just so much information, then you begin to try to make sense of everything that was said by the business team. So you notice that a participant interacts with the task through something called board somehow. And the columns are divided according to the status of the task. The backlog has tasks that are planned but not accepted yet. The project velocity is calculated by the backend somehow. They didn't mention how it's calculated, but that's okay. And the project velocity is used to separate the backlog into sprints. It's possible to simulate the velocity in the front end, so you can ignore, at some point you can ignore the data that you got from the back end and just simulate this velocity. And again, there's a lot of other stuff that you understood, but we're not gonna too deep on that right now. But then you begin to notice some characteristics of the front end. So a lot of that was talked by the UX team and the product team. They're not just visual rules and behavior. There's not just UI. There are actually visual representations that implement and enforce business rules. There's just the UI part that enforces and makes that business rules be respected by the user. So it means that the front end even has its own set of particular concepts and business rules. There are some of those rules that only apply to the front end. And the front end even has its own ubiquitous languages. Some of those terms that was used during that explanation by the UX team and the product team were very particular just to the front end, meaning that the front end has its own domain model. So it led you to think that the front end belongs to its own bounded context. So even though we didn't see the front end there, in that initial context map, after some conversation with the UX team and the product team, you notice that you do have a bounded context for the front end, and we call it the board. And if you think more about it, you even can see that this bounded context has some relations with the other bounded context of your context map that you had in the beginning. And that's just the starting point of what we're going to do in this talk. But of course, it comes with some challenges. Like doing DDD on the front end is not something that's very common. And if you try to implement it, you're going to face some challenges that we're not expecting. So the first one is ensuring the model integrity. Why is that a challenge? So the thing is that the browser can be relied on as the source of truth. So if you have a domain rule that is shared between the front end and the server, and it's performed by the front end, the server can just automatically trust that the front end did it correctly. Like it's not very safe to trust the browser to be respectful of what you expect of it. And also, domain logic on the front end is a matter of UX. Of course, you can move all this logic to the back end, and after every change in the front end, you just send a request and let the server validate it for you, but it's not very good UX. Like the user is going to have to wait all the time and see spinners all the time. So it's also a matter of UX to have a good product, to have some domain logic implemented in the front end. And of course, we can ignore those technical limitations. Like you need to ensure the model integrity, but also you can rely on the front end to ensure it. How do you work with that? Okay, so how do we ensure the integrity of the model on the front end? I'm going to start with an example inside this project management tool, which is a use case of when a participant creates a new task. So let's begin by defining what is the composition of the task aggregate. Again, I'm going to list some of the properties of this aggregate here. You don't need to focus on all of them, but it's important to know that they exist. So a task aggregate has an ID, which is unique, a title, which is unique inside a project, a description, which is optional, a type, a status, a requester, and an assignee. Both of them are participants of this project. An unplanned and unstarted task might not have an assignee, like nobody was assigned to work on that yet. An estimate that can be one of those numbers, and only for planned features like bug fixes and chores does not have estimates. And a priority, which is a number, and the lower the value, the higher is the priority, like it was a place in a priority queue. And also there are some business rules that apply only for these use cases when the participant creates a new task. Like a task should never be created in an accepted state. The participant who created the task is automatically set as the requester, and a task is always created with the lowest priority at that moment. And the user, if they want to make it a higher priority, they can just drag and drop it later. Okay, so this is the form where this use case is going to take place. This is the form where the user is going to interact. So we might assume that this form represents a task, right? I mean, let's check it out. So we have the title, we have an estimate, the type, the status, the requester and the assignee, and the description. I mean, it does represent a task, right? Right? I mean, okay, how do we ensure that this title is unique while the user is interacting with it? Or even how do we know what is the lowest priority to set it to the task while the user is still trying to create a new task? Or even how do we create an aggregate ID in the front end if we can't rely on the front end to do this kind of logic? Okay, so we know that this form does not actually represent a task because most of the invariants that we set for the aggregate of the task can be ensured in this moment. Okay, so what is the challenge of aggregate design on the front end? The thing is that some invariants conform to models that are implemented on the back end. So changes on these aggregates on the front end, they just can be trusted until they're validated by the back end. And there's even the special case of generating an ID, which we might assume that is possible to do on the front end, but we can't trust the generating algorithm is legit. And even if you use something that is native from the browser, like the render UUID function, it could be spoofed by the user somehow. So every time you have something like this scenario should be designed accordingly, considering the technical limitations of the front end. And it smells like a lot like an implicit concept that is missing there that should be made explicit. So right now, what we might be assuming that the flow of this use case is like we have a form in the front end, and this form represents a task, and the data of this task is sent to the back end, which creates the task, respond with the data of that task created to the front end, and it's used to be rendered by the front end. But we already know that this part is a lie. We already know that the form does not represent a task. So what is it then if it is not a task? So you go back to that cloud of words that you elaborated in your mind while you're talking to the product people and the UX team, and try to find if there's some missing concept there that you just skip it during the conversation. And after trying to remember everything they told, you remember that there was a talk about a task draft, which is not exactly the task, but it was the data of the task while the user was still creating it after they click the plus task button. Okay, so now with that in mind, you try to create the new flow of that use case, trying to make it fit your domain model. So now you have a form in the front end, and that form represents the draft of a task. And after the user tries to finish to create the task, they're going to send the data of that draft to the backend. Then the backend is going to use the data of the draft to create the actual task, and they respond with an actual validated task to the front end, and that data is provided to the front end to be rendered at some point. So now it kind of makes sense again. Like we didn't define what is the task draft yet, but we know that the task draft is not a task, and since it's a task, I think my microphone is. Since it's a draft, it should be correct, right? I like to call this design pattern the permissive and the validated aggregate. So what is that? What is the validated and the permissive aggregates? So it's common for front-end aggregates to conform to some back-end aggregate in a way that they need a permissive counterpart to be able to handle all those business rules on the front end. This counterpart represents the intent to create the actual validated aggregate on the server. We call this, in this talk, we're going to call this the intent of creating that validated aggregate. We're going to call it the permissive aggregate. And the thing is that the domain rules of the permissive aggregate, they're looser. They're more flexible in a way that the user can bend those rules until they're ready to attempt to actually create the validated aggregate. And after persisted by the server, what we get back by the server is an actual validated aggregate, because the backend is going to be the one that is going to validate that aggregate. So in this scenario, the permissive aggregate only exists in the front-end model. It's specific to the front-end. And the validated aggregate is a concept that is shared between the front-end and the back-end. So here's a small example implementation of how to do that with TypeScript, for example. You can, for example, have the validated aggregate is a task, and you can even use the type system to make sure that all the business rules are being respected and enforced. Because once you have a task, you're totally sure that all the business rules are being followed. And then when you have the permissive aggregate, the rules there are looser, so you don't need to have some strict typing for that. You can just leave it for the use case to handle, and then when you send it to the backend, you're finally going to validate it and get a task back. Which leads us to having to deal with invalid states. Like, if the user, if you have an aggregate that have looser invariants, you're going to lead us to have invalid states. How do we handle that? How do we accept some invalid states on our domain? It should be illegal. So if you go back to that form, the user, while the user is interacting with it, they might face a front-end validation. Like, for example, if they try to save, but the status is not there, this is a front-end validation error. Or even if everything seems correct in the front-end and they try to persist it, the server is going to say, wait, there's some missing rule there that you didn't respect, and then respond to the front-end that they can't validate it. They can't get a validated aggregate back. So how do we handle errors in the permissive aggregate? So the thing is that we should model the permissive aggregate as something that has error states as part of its life cycle, not something like an exceptional case. In this way, if you do it this way, you're going to see that that part of the model is going to fit your domain model very nicely. For example, if you think about a draft is something that is still in stage of elaboration. It's not something that, when it has an error, is an exceptional case or something that is broken. It means that as a draft, it's okay to have errors because this is part of its life cycle. Or even a payment attempt. Like if you're implementing some payment flow, until the payment is confirmed by the payment service, you don't have an actual payment. You just have the attempt for that payment. We could enumerate some other examples here, but the important part is that you're going to model that part of your domain as something that can have errors in its life cycle. But how do we represent it in code? How do we actually represent that flow in the code? So what I usually do is I create a type that is a union between my validated and the permissive aggregate. I usually use the prefix any, but you can use whatever your teams prefer. And then you have a type that represents all the possible errors that the permissive aggregate might have. And then what we're going to do is create some functions in the front end that, as I said before, every time you have some business rule that is going to be enforced on the front end, even if you pass a validated aggregate, what you get back from that operation is a permissive aggregate. You can't just trust the front end to be generating a new validated aggregate. So, for example, here, in this the change title example, even though you can receive any task, like you can receive either a draft or a task as an argument, what you're going to return is always a draft. What you're going to return is always the permissive aggregate. And you're only going to transform it into a validated aggregate once the backend says that it's validated. And then in the last part, you're going to have a function that receives that permissive aggregate and then return some set of all the errors that might be present in that permissive aggregate. And notice that all of those happens only in the front end. None of this code is making any requests. This is just the main code. So that was an example, but there are some implementation guidelines that I like to follow when trying to implement the permissive and the validated aggregate. So prefer plain objects and functions instead of classes because they're simpler, they're more flexible, and also they matches the pattern of the community. Most of the front-end community right now does not use classes to represent concepts. And it also works way better when we use immutability. Like when you're using classes and you want to generate a new version of some immutable variable, you can just spread the variable like we usually do with simple objects. So in order to use immutability, it's better to prefer plain objects and functions. And also, when you use immutability, it's going to work way better when consumed by the UI or the state management technology that you're using in your application. In a way that you don't need to do all those kind of dirty checking or any of those. You can just trust the immutability to be respected by the whole application. And I also suggest to use TypeScript because it's going to make types and concepts explicit in the code. When you use it just pure JavaScript, there are some concepts that, since they're not ever going to show in some variable name or something like that, they're not going to be actually explicit. So by using TypeScript, you're going to make all these concepts explicit. And since we're already using TypeScript, what we're also going to do is collocate types and functions, the operation of these types in the same place, in the same file, in a way that a class would force it to be. A class would force it, the behavior and the data to be in the same place. But since they're separated now, we can just improve it, making them in the same file. So how do we hold invalid state in the permissive aggregate? So after a validated aggregate change, always return a permissive aggregate. And if you want to make it some like math notation, every time we perform a domain operation passing a validated aggregate, what we get back is a permissive aggregate. And then have a function that tells everything that is invalid on that permissive aggregate. At sometimes, you get an error back from the backend, and you need to save it somewhere inside of some object, and you can put it inside the permissive aggregate as well. Just make sure that you don't access that property of that object directly. Use that getErrors function for that. And then rely on the backend validation only when you're trying to persist. And since we're talking about persistence, it leads us to talk about repositories. So repositories on the front end might sound a little weird, but let's investigate it. So front end repository usually interact with APIs like REST APIs, GraphQL, or WebSocket, or whatever, or even the browser API like local storage or IndexedDB. When you're trying to persist a permissive aggregate, what you're going to do is perform a front-end validation first, and then if everything is correct with that front-end validation, we're going to send a request, leaving the backend to do the final part of that validation. And then if everything goes back with that request, what we get back is a validated aggregate, in a way that only the server is able to validate our permissive aggregate. And then the repositories are the place to assign this kind of responsibility. If you have this flow of validating the front end, sending the request, and then mapping back to the model of the front end, the place to do that is the implementations of the repositories. So here's an example of an interface of a task repository that would be implemented in the front end. And notice that in the store method, what you're going to receive is any task. Like, it's not just the task or just the draft. You can pass any of those, but what we get back is always a task. Once we get, we're sure that the front end, the backend response is a validated aggregate, what we're going to get back is a validated aggregate. And the same can be said about the getters. So if you're trying to get some task using the task ID, what you're going to get back is the validated aggregate. It's never the permissive aggregate, because the server only responds with validated aggregates. So this is the kind of interface we would use for a repository in the front end. But maybe you're wondering, like, aren't the APIs way more restrictive than databases? Like, what if I don't even have the endpoints to implement everything that I need in my repository? And you're correct. So let's think about this example for a while. And let's pretend that this code can be run both on the backend and the front end, like in a Node application in the backend is going to use an actual database. And then you're going to also use that same code in the front end, interacting with an API. So if you're in a database, in a repository that uses a database, it's going to be kind of trivial, right? What you're going to do in this scenario, you just mostly use an update carry in a way that you're going to update the task table, and that should be okay. But it gets trickier when you get to the front end. Like, let's say that you have, for this specific occasion, you have two different endpoints that could be used there. One of them that are used only when you change the status of a task, like when you try to start the task, and the other one that can be used by any other change on that aggregate. So how do we decide which endpoint to use in this scenario? This sounds a little bit trickier, and it's kind of like dangerous to take wrong decisions based on that. So it's also important to take care not to make your repository just a proxy of the API, creating a repository method for each of the endpoints. This is not the purpose of the repositories. So we should not create like a store method just to use one of the endpoints, a start one, and assign one method of the endpoints. The thing is that we should not do that because the repository should not be an API client. The repository should not reflect just the endpoints that the API exposed to the front end to consume. So how do we interact with restrictive APIs in front-end applications? So when the relation between the API's bounded context and the backend is a partnership or a customer supplier, it's mostly fine. You can just talk to people and see if we can get to a middle ground where the backend is going to accommodate the needs for the front end. But it kind of becomes a problem when the front end is conforming to external service, where you don't have a say about what are your needs. So we have two main scenarios that might arrive in this kind of situation. So the first one is more than one endpoint is needed to fetch a single aggregate. So for example, let's say that you're going to fetch the project aggregate, and you need to hit the project ID endpoint to get most of the data of the project, and then hit a second endpoint just to get the settings of that project to build the project aggregate on the front end. And there's an even trickier one, which is when you have a different endpoint to each different change that can happen in that aggregate, which is the example that we just saw in the last slide. Okay, so let's tackle the first one. Okay, so what do we do when more than one endpoint is needed to fetch an aggregate? So the first thing we're going to do is checking our model and ask ourselves, is it actually a single aggregate? Like, is it possible that I'm trying to oversimplify it on the front end, but it should be actual more than one concept there? And if it's not the case, like if it's actually more than one aggregate, you can just like refine your model in a way and then design your code accordingly, considering the new scenario that you just got. But maybe it is more than one. Maybe it is a single aggregate. Maybe you're going to need to hit more than one endpoint to build that single aggregate. So if it is the case, then check the relation between the front-end bounded context and the API's bounded context. Like, can the API be changed to accommodate those needs of the front end? And if it is the case, just ask them and get to a middle ground, and that should be okay. But maybe you really need 2 or more requests. And if it is the case, it's going to get a bit trickier, but it's the first question to ask yourself is if one of the requests fail, can it be retried? Like, is it safe for me to retry one of those requests, risking to not getting like some inconsistent state at that point? The other question is, are there some safe fallbacks that won't hurt the model integrity? Like, if some of the requests fail, can you fall back to some hard-coded data in the front end in a way that it won't hurt your model integrity when you try to send that request to the back end? And then if nothing else can be done, it's just okay to throw an error. Like, even though part of that aggregate was already fetched, it's okay to just throw an error instead of just trying to show just some part of that in the front end. Like, it might lead you to more trouble than benefit. And there's this second scenario that when we have different endpoints for each change that happened on the aggregate. So the first question that we ask ourselves when this happens is it possible to infer which endpoint we're going to use solely from the aggregate data? Like, can I check the current state of that aggregate and then decide which endpoints to use just on that? If it is the case, you can just encapsulate this logic of deciding which endpoints to use inside the repository and then move on. That should be okay. But maybe it's not the case. Maybe you just can't see what endpoint to use at that point. And then you ask yourself, is it possible to infer the endpoint knowing what changed? Like, if I see what was the previous state and then the new state and know what happened between those two states, is it possible for me to decide which endpoint to use? If it is the case, then you have 2 possibilities there to tackle that. The first one is using domain events to track the changes inside the aggregate in the front end in a way that every time you do some change on that aggregate on the front end, you just push that event object inside your permissive aggregate and then check that when you're going to decide which endpoint to use. And the other option, which is a little more complex but can be more useful at some points, is comparing the aggregate before the change with the new version of it. And then doing kind of a diff to decide which endpoint to use. And if it is the case, you're going to need to keep a copy of every fetched data inside the repository instance. I know it sounds like too much, like We should not do that, but the thing is that we're probably going to do it anyway because we're going to need to keep that data to show it in the front end at some point. So if you're using a Redux store or even some fetching library like 10-stack carry, which has a cache on there, you're going to already have the access to the previous value of that aggregate in a way to compare, to decide which endpoint to use. And for each of those cases, you can encapsulate this logic again inside the repository in a way that it doesn't leak to the rest of your model. Okay, so how do we actually implement it? I know it sounds easy the way I describe it, but it must be trickier, right? So let's begin with this example implementation of the task repository called API task repository. Since the store method is a little longer, I just put some of each of those methods in the separate slide. So for the getById method, what we're going to do is that we're going to use some kind of API clients that abstract the access to the endpoints of that API for us. And then after we get the response from the API, what we're going to do is using some kind of mapping from the shape of the object that comes from the API to the shape of the object from our front-end domain model. And this is the important part. After that data is fetched, we're then going to dispatch a Redux action in this example, but you can also rely on 10-stack carry for that. But we're going to use dispatch a Redux action here to let the Redux store know that, okay, that data was loaded. Save it because I might need it later at some point, and then pass the data of that task. And then get to the trickier part, which is the store. Notice that, as we've stated before, the store is going to receive any task, so it might be either a task or a draft. And if the first thing we're going to check is if it has an ID, and if it does not have an ID, it means that it's a draft. So the first time we're trying to persist it, so we know for sure that we can just use the post endpoint, and then just send that data, map the data of the draft to the params of the API, and then map back to the front-end domain model, and then dispatch a Redux store action just to let the store know that, okay, a new task was created, store it for me because I might need it later. And then if it does have an ID, the first thing we're going to do is get the old version of that aggregate to make this kind of comparison. I use an example Redux selector there, but you can just get this data from the Redux store anywhere, any way you want. And then I do that using the ID because now I know that the ID exists. Like I did that check at the top of that method. And then I'm going to check for all the possibilities that might arise and impact in the decision of the endpoint. So I check, is it only the status that changed? And if it is the case, I know that the endpoint that I should be using is that one where we post to the endpoint that points to the new status of that task. And then after all those changes and all those requests, we're going to let the Redux store know that some task was updated. And then if I call it again, we're going to be able to get the new version of it using that selector. And then after all of those logic, we can just rely on the last possibility, which is when you have this patch endpoint. Of course, this is just a small example, but there might be cases that we have like 4 or 5 endpoints that seems to be similar, and each of them apply to a different occasion. So you can just encapsulate this kind of logic inside the repository implementation, and then use something like the Redux store or the caching of 10-stack carry to do this kind of comparison. And then you also might accept that sometimes a repository is just not the answer for what we're trying to do. So if a repository is effectively adding more complexity than it's tackling from your domain model, or even it just won't fit nicely on your domain model, just accept that a repository might not be the answer for this scenario. It might happen. That's okay. And if it is the case, consider implementing an external application service, kind of similar to what we do with service-oriented architecture, that encapsulate the access to that order-bounded context. For example, in this example, if the task repository is actually adding more complexity than removing, we could create an interface called task service, and then create an implementation called HTTP task service or API task service that will actually interact with that external service for us without needing to respect all the rules that we would expect from a repository. which leads us to talk about context mapping. So the thing is that most production-grade front-end applications consume at least one API, at least one backend. So if you're using DDD on the front end, context map is going to be a constant. Like we're going to have to need to map between the model of that backend that we're consuming and the model of the front end. And most of the front-end bounded contexts, they are either in a partnership relation with other bounded contexts or in the downstream side of any type of relation, any other type of relation. So this is something that you can notice in that example that we shown before. Like we have the partnership there, some of the customer supplier, but the front end is always in the downstream side. So at this point, when you're facing the challenge of implementing context mapping between the front-end model and any other model that that front-end is consuming, the first thing we're going to do is discover what are the proper relations between the front-end and the other bounded contexts. And then we're going to use the repository and then the services to do all the mapping and then translation between those bounded contexts. And then you can use the mapping and the translation part to avoid the front end for being corrupted by the API domain model, or even some stuff that are simpler like the variable and attributes casing, and even hiding like the existence of HTTP status that are specific to that endpoint that should not leak into the domain model of the front end. And also take a lot of care not to implement every relation of the front end as if the front end was always a conformist. It's not because the front end consumes an external API that all the domain model of that API should be leaked inside the domain model of the front end. You don't even need to use the same terms if it's not something that you do in your model. So for example, if you go back to that example implementation of the repository inside the API repository that we had before, we can see that at that point we had some kind of mapping between the draft that is particular to the front-end model. And at this point, we noticed that, okay, looks like the front end, the back end actually calls it points instead of estimate, but we don't call it points in the front end. So the place that we're going to do this mapping in a way that we protect our front end to using that points name that is not present in any other place of the front end model is inside this mapping, is inside the context mapping that is called by the repository. And even something that are simpler, like let's say the API uses snake case, but our front end uses camel case, we can do this mapping on the mapper as well. And the same can be done in the other way around. Like when we're receiving, mapping back the domain model of the backend should be consumed by the front end, we might do the way back. So we're going to convert the points attributes to be called estimate and then convert the casing as well. So before ending this talk, I want to also give some additional insights that are not exactly linked to using DDD on the front end, but are relate to using DDD on the front end with some kind of software architecture. So the first one is using domain events in the front end. So it's important to understand that it's okay to use domain events in the front end. They play the same role as they would do in any other context. And don't make it's not because the front end can handle domain events that they should be, that the front end should be responsible for preserving the server domain model. Like if you do have some kind of events that should be orchestrated to ensure that the integrity of the model is respected throughout the system, this should be moved to the backend, because the backend might have some retry mechanism and stuff like that the front end can be relied on. And if possible, and if you're going to use domain events in your front end, use the same mechanisms used by your repositories and services to track changes. For example, if you're using Redux, you can just use Redux actions to dispatch your domain events after some persistence is confirmed inside of repositories. And if you need to convert, like you need to translate some domain event into some system event. Let's say you have some part of your application that after some domain event happens, they're going to show an alert to the user or something like that. Also try to use the same mechanisms as the rest of the events. For example, if you're using Redux, you can use the Redux Toolkit's listeners API to listen to some domain event that happened that was dispatched by your store instead of just creating a new mechanism just for this part. And also, I want to talk about stateful use cases. So the thing is that most of the backend use cases are usually transactional. So the user tries to do something, and if they are not able to do that, they got to start over. But it's not the case for the front end. Most of the use cases on the front end are stateful. The user is going to see some error scenarios and some other different tracks or possibilities of the endpoint of the use case before the use case finishes. So try to reason about front-end use case as there were the implementation of the saga pattern or state machines in a way that between each state of that use case, there's going to be user interaction that generates new events. And then the permissive aggregates can be used at least as part of the state of that use case. This is the whole reason of why the permissive aggregate is necessary here, because we're going to need some domain rules to be ensured inside the use case that is stateful. Initially, we might assume that the way that the create new task use case worked something like this. So the user clicks the plus task button, and then the user inputs the data in the form. The user clicks the save button, the end, and that's okay. That the user is happy. But it's not that easy. It's not how it works. So this is an oversimplification of how actually use cases usually apply on the front end. Like it's actually a state machine that can lead to invalid states and for various reasons, either front-end reasons or the server reasons. And then when the user gets to the end, like it's a whole interaction between the user and that UI. It's not that simple as we would expect and how it would be in the front end. It's not transactional. It's stateful. So here's an example implementation of a use case on the front end. I hope it's possible to see it. So the first thing that we would do is create the initial state for that use case. In this case, I created the whole state of that use case is just a draft, but it could be an object containing the draft inside of it. And then we have the interface for that use case. That interface is going to have injected the current state of the use case and then a setter to update the state of that use case. And then inside that interface, what we're going to implement is all the methods that we're going to do and going to expose the UI to interact with that use case. For example, here we have the change test title that's going to receive the new title, and then use the set draft to update the draft to a new value. And then we can create all the other functions that belong to that use case that are going to be exposed to the UI to consume. And then in the end, we're going to have a single method that's the one that's trying to finish and end that use case. In this example, I called it create task as well. And it's going to use the task repository to store that draft. And then we're going to return all the methods that are important to interact with that use case in a way that the front end can use that, the UI code can use that to interact with this use case. But at this moment, this code doesn't look very useful, right? Like, we know that we're going to inject the draft and the set draft, but how do we actually use that? So here's an example implementation of how to adapt that implementation to be consumed by React. So the first thing we're going to do is create a custom hook. Here I called it use create task. And then we're going to generate the initial state of that use case to be stored inside the use state hook of React that very conveniently returns exactly what we need, like the state and a setter of that state. And then we're going to pass that state and the setter to our interface, and then going to return it to the from the hook in a way that the UI can, the component of the UI can use that. And just for performance reasons, we're going to use the use memo from React, just so we don't create a new instance of the interface except when the state changes. So, so what are the lessons about implementing use cases on the front end? So the first thing is that we should implement use cases on the front end isolated from the UI. And then we're going to adapt that implementation to be consumed by the UI using the lifecycle and some established patterns of the UI technology that we're using. For example, if you're using React, you're going to use some of the hooks and the custom hooks, which are the lifecycle and some an established pattern of the React community. Or if you're using Vue, you can use Vue with the Reactivity API. Or even if you're using Flutter, we can use the block design pattern to encapsulate and then adapt that use case implementation to be consumed by the UI. And by doing that, we leave the reactivity and the state management for the UI layer to implement. The use case does not need to to care about how the reactivity or how the state management of that value of the use case is being handled. This is implemented separately in a way that just the UI needs to care about that, in a way that's more convenient for the UI. And then after all of that, the rest is just canonical knowledge. So the thing is that some part of your bounded context only exists on the front end. And if it is the case, if you have parts that only exist on the front end, you can model and design these parts the same way we do for anything else. Like, it's not something too different. Like, if it only exists on the front end, it doesn't depend on any other bounded context, that's okay to model as you would do in a backend bounded context. And it's important to think that you don't need microservices on the front end to have multiple bounded contexts on the front end, in the same way that you don't, micro frontends. The same way you don't need microservices on the back end to allow you to have multiple bounded contexts on the back end. And of course, DDD won't ignore these technical limitations that we're trying to tackle in this talk. Like, we do know that the browser can be relied on as a source of truth, but it doesn't mean that DDD in the front end is a completely different thing. This is not the case. You can see in this presentation that there are a lot of stuff that you can do before just assuming that DDD in the front end is not possible. So before finishing this talk, I want to just leave some key takeaways based on what I've been talking about. So the first thing is that remember to talk to domain experts and the UX team. They're usually in sync. They're going to use the same ubiquitous language that you're looking for. Discover any implicit concept that should be made explicit, and don't be afraid of creating new domain concepts only for the front end to make your domain model work. Discover your domain model of the front end by separating what is just UI behavior for what is actually visual implementation of domain rules. Try to protect your domain code from technical limitations, but also accept when technical limitations cannot be circumvented, and then you need to be creative in a way to make it fit in your domain model. And also, the most important part is try to use canonical knowledge as much as you can, and then adapt when necessary. Thank you, DDD Europe.